Hi, my name is Professor Mazzella, and I teach a course in basic electricity at Queensborough Community College. I find that my students often have a difficult time understanding how to measure a current in a circuit. And the idea of measuring a current is to break the wire, insert the meter in the circuit between the broken wire ends, and you measure the amount of electrons passing a given point in a given time. To demonstrate that principle, I've developed this device, and what it is a pump. You can see in this water trough, and when I turn on the switch, the pump runs water through the hose. You can see it coming back into the reservoir. And my question to you is, how much water is flowing through this pipe? It would be analogous to asking how much electricity is flowing through a wire. Well, there's one way of telling how much water is flowing through the pipe. So if I take the pipe out of this reservoir and put it into a container, and then measure the time it takes to fill the container. Let's say it takes 1 minute to fill a 1 quart container. I could say that this pump is producing 1 quart per minute of flow. But sometimes I want to know exactly what's going on this instant, not what happens after a minute or so. So I developed this little device, and I'm going to change this broken hose, or this hose connection in the middle, to the device that I have to measure the amount of flow instantaneously. So first I shut off the water flow and let the system drain out. And then what I'm going to do is take my flow meter, which will tell me how much water is flowing through the pipe, because there's a little paddle wheel in the bottom that spins, generating a signal to go into my meters to tell me how fast the water is flowing. So we're going to put that in the loop. First I have to make sure there's no water to drain on this nice clean tablecloth. Set nice and straight. Now what I'm doing is taking the output of my little generator, which is a wheel that spins in the water flow, and I'm hooking it up to my meter. And I have 2 meters. I have an analog meter here and a digital meter. And another aspect of this device is to demonstrate how convenient it is to have an analog meter as opposed to a digital meter, which is very exact, but you have to read the numbers carefully. In the case of the analog meter, I can look quickly at the gauge and see that it's halfway or 3/4, and if that's adequate, I don't need to know the exact number. I just need to know how it compares to a mark on the face of the dial. So I'm going to turn on the water flow, make sure all the hoses are connected so I don't have a flood. And here we go. Okay, so the water is flowing through the pipe as it did before. But because there's a paddle wheel at the bottom of this measuring device, the paddle wheel spins and I generate a signal that reads that on my voltmeter, both analog-wise and digital-wise. Now, you can see the needle is about 3/4 of the way, and if my criteria was to have the needle at least halfway, then I can very quickly, I'll turn it off and we'll start it again. I can turn it on and very quickly look at the meter and say, oh, it's past the halfway point, and that's adequate. I don't have to look at the digital meter and analyze the numbers and make a comparison. Now, what I also have to show that I can restrict the water, which is similar to putting a resistor in the flow of electricity, in a circuit with electricity. So by putting this clamp on the hose, I am simulating an electric circuit with a resistor being put on in that circuit. So here again, you can see the flow is about over here. As I tighten this, forcing a resistance to be put into the circuit, You see the meter went down a little bit because there's less water flow. That's similar to less electrical flow. Again, I can turn the resistance, increase the resistance, reducing the water flow, and the needle goes down to a lower value. If I want to decrease the amount of resistance, I loosen the clamp, and the water flow goes back to where it was. So what this demonstration device does, it shows you that to measure the flow of current in a circuit, you must break the wire, as I did by breaking the tube, put a measuring device in the circuit that measures the amount of water flowing in this case, or the number of electrons flowing in an electric circuit, and that's the method of determining current flow, by breaking the wire, inserting your meter between the two broken parts, and the meter will read how many electrons are flowing. Thank you very much for your time. I hope